Hello, class. Today we're just going to go over, basically take what we've been doing and kind of expand on it, and basically graph part of the graphs and kind of put them together. It's called piecewise functions. So piecewise functions, and what that kind of just means, piecewise, is you're just kind of putting pieces of functions together to make a cooler function, I guess. So it looks more intense is a good way to put it. But before we do that, I kind of want to go over just a couple notations and that kind of stuff. So if I had, I just want to kind of go over f of x. F of x is the same thing as saying y equals. The reason why we use f of x is to note that it is a function, and so let's just do equation 3x minus 5. So we have the same exact equation, but if I wanted to plug x in to the top equation, which is f of x, I would note it, or do it by saying f of 2 equals 3 parentheses 2 minus 5, and I would get 1, correct? If I did it in the other notation, into my y equals, I would have to sit here. I know it sounds like you're writing a lot, but like I said, math people are lazy. They hate writing. I'd have to write x equals 2, and then I would plug it in. So it's just kind of an easier way to plug in variables, plug in different functions, so you can have a function of a function, which we'll get into that as well. But I just want to kind of go over piecewise, since we just went over parent functions. I figured this would be a good tie-in. So I'll note it as f of x. So if I wanted to grab f of let's start with the linear parent function. We'll just make it 3x plus 2. Correct? If I wanted to graph that function, I'd start my y-intercept, which is 2. I'd put a dot. I'd then go, so m equals b equals. Start at 3 and I'd go up, or start at 2 and I'd go up 3 over 1. So that's what my parent function will look like. But when we talk about piecewise functions, we take that normal function that we have, 3x plus 2, and we basically say, I only want to see part of the graph. I only want to see values of x greater than 1, or x greater than 2, or x less than 0, that kind of stuff. So I'll scroll up, and we'll just erase everything. So I'm going to take f of x, and I'm going to graph 3x minus 2. But I'm going to limit my function by saying that x is less than, we'll say 0 for right now. So what I'm going to do here is, in my head, I'm going to graph that function we just did. So it's going to look like that. But I only want that part of the graph, because this is where x is 0 at, and I only want the left hand of the graph. So when we talk about graphing this function, I'm going to start at 0, and I will erase that. I'll go over why I erased that in a second. Alright, the reason why I erased that is because how I noted it, or did my notation. It's saying x is less than 0. It's not saying x is less than or equal to 0. If we're less than 0, it's going to be an open circle, and now I would go and graph that part of the graph. So that's all the piecewise function is. So we're just going to put two functions together. And so how we note two functions are together, we just kind of do f of x, and we set up. So we'll set up 3x minus 2 for x less than 0, and we'll do my favorite graph. We'll do the square root of x, where x is greater than or equal to 0. The reason why these are off, one's equal to, one's not equal to, is the same reason that why functions are functions. my x values can't repeat. If they both equaled 0, it would not be a function because I'd have an x value going to two different values. So in the piecewise functions, we want to make sure that they stay a function. So I'm going to graph exactly what we just did. Go up to 2. So there's that function. And now guys, the reason why I wanted you to have every parent function memorized is because, well, what's the square root of x? Well, I know exactly what that looks like. It's going to start at 0, and it's going to go that way. So this would be my piecewise function of the linear function and the square root function put together. So this last example that I want to go over, I'm going to write it down. Y'all are going to press pause. You're going to try to do it, and then y'all are going to watch the rest of the video. So it's kind of like doing practice. And once again, guys, if you have a question, come for tutoring, watch the video again, or make up your own piecewise function and try it before y'all get homework tomorrow and work on it in class. So I'm going to so that's shifted over to the right 2 units. So here I'm going to say x is less than or equal than 2. And then I'm going to do my favorite function, because it's a superhero. I'll do absolute value of x minus 2 minus 3 for x greater than 2. So once again, guys, here's the function. I want you to pause it. I want you to try to graph this. And remember, your graph, I would start with the top and work the way down. Graph the first one first. It's an x squared. It's a parabola. It looks like a u. And then go from there. Welcome back, class. Hopefully you did graph it on your own. So the first function I'm going to graph is the quadratic function. It's a quadratic shifted over to 2 units. So it is a closed circle. If you kind of want to make those marks there on the before you graph, that might help out. So if I plug in 2 to this function into the x squared, I get 0. So closed circle, and then it's just going to go up like this. The absolute value function. If I plug in 2, it gives me -3. So I'll plug in a -3. I know it's an open circle, and then because the shape, I know it's a V, it's going to shoot off like that. So that is the piecewise function. That's all the notes I'm going to go over because I don't want to go over too much. Homework tomorrow, we'll work in class, get in groups. If you have any questions you have, I'll either answer them in class, or you can come by in the morning. Have a great night.